Welcome, my dear student, in our math program for secondary 3. Dear student, today we are taking the first lesson in solid geometry. What is the title? Geometry and measurement in 2 and 3 dimensions. Look at the 3 dimensions orthogonal coordinate plane. Look at the figure. First, determine the position of a body on a straight. It is necessary that to know distance between this body and a fixed point on the straight line called the origin point. OA equal x belongs to R. Look at, dear student, 2 dimensions plane OX and OY. This point A, to determine the position of a body on a plane, it's necessary that to know coordinate of this body on 2 coordinate axes. A point xy, or position point of the body A, is OA, or point A xy, ordered pair belongs to R square. What do you mean R square? 2 dimensions. 2 dimensions, we have 2 axes OX and OY. But how to determine the position of a body in the space? The 3 dimensions coordinate system are power 3. The coordinates of a point A in the space is determined with respect to 3 axes meet at a point, and mutually perpendicular by determine the coordinate of this point on each axis. We have 3 dimensions, OX, OY, and OZ. Dear student, we have OX, OY, OZ, 3 orthogonal dimensions in the space. Look at the point A. Lie on OX. The first projection is X. The second, 0. Third, 0. Why? Because this point A belongs to OX. The coordinate of X is X, but coordinate of Y 0, Z 0. Look at the point B. Lies on OY. The first is 0, second is Y, third is 0. Projection or first projection 0, third projection 0, the second projection Y. Point C is 0, 0, Z. Why? Because C belongs to OZ. Then the first and the second coordinates are zeros. But look at, dear student, the point D. Doesn't lie on X and on Y, OY, and doesn't belongs to OZ. Then the point D has 3 dimensions, X, Y, Z. Point E. Look at, dear student, point E, X, Y, Z. Remember, dear student, ED parallel to OZ. Then the coordinate of Z is 0. Point F lie on the plane XZ. Then F is X 0 Z. Dear student, look at the point E lies in the plane OX and OY. The point F lies on the plane XZ. Then the coordinate of Y 0. Point H lies between OY and OZ. Then the coordinate of X is 0. Then H equals 0, Y, Z. Look at the right hand rule. What is the rule of right hand? The figures of the right hand refer to the positive direction from x-axis to positive direction of the y-axis, and refers to the positive direction of the z-axis. Look at coordinate planes. All the points in the space whose coordinates x, y, 0 lie in the coordinate plane xy, and its equation z equals 0. Number 2, all the points in the space whose coordinate x, 0, z lie in the coordinate plane xz, and its equation y equal 0. 3. All the points in the space whose coordinate 0, yz lie in the coordinate plane yz, and its equation x equals z, x equals 0. Look at example. Dear student, determine the position of the following points in 3 dimensions coordinate plane. Look at the point -2, 3, 2. Point B, 3, -1, 5. Point C, 4, 0, -1. To determine point A, -2 in x, 3 in y, 2 in z. We determine the point -2, 3 in the plane xy. After that, move in the positive direction of z axis 2 units to obtain the point A. To determine the point B, 3, -1, 5. How to determine x and student? We determine the first, the point 3, -1 in plane xy. After that, move the positive direction of z-axis 5 units to obtain the point B. Another example. Dear student, complete the point -1, 2, 3 at a distant units from the coordinate xy. X and student, 3 units. Y coordinate plane, this point we determine -1, 2 in plane xy and move 3 as positive direction z-axis to determine the point -1, 2, 3. Then this point -1 in OX, 2 on OY, 3 on OZ. The point for -2, 1 at a distance. Look at the point. How to determine this point? We determine the point for -2 in coordinate plane xy and move 1 unit from coordinate yz. The distance between 2 points in the space. Dear student, in the last, when we find the distance between 2 points, the first point in 2 dimensions, remember, point A, x1, y1, point B, x2, y2. When we find AB, or the distance between AB, we write AB equals square root difference between 2x square plus difference between 2y squared. AB equals square root x2 minus x1 for all power 2 plus y2 minus y1 for all power 2. This rule in 2 dimensions, but when we translate in 3 dimensions, we find AB equals square root x2 minus x1 for all power 2 plus y2 minus y for all power 2 plus z minus z1 for all power 2. The distance between 2 points in the space in 3 dimensions, if A equals x1, y1, z1, B x2, y2, z2, and 2 points in the space, then the distance between A and B is AB equals square root x2 minus x1 for all power 2 plus y2 minus y1 for all power 2 plus z2 minus z1 for all power 2. Example. Prove that triangle ABC where A equals 2, negative 1, 3, B negative 4, 4, 2, C negative 2, 5, 1 is right angle triangle at C. AB, dear student, what is the rule? Distance between OAB, x2 minus x1 for all power 2 plus y2 minus 1, y1 for all power 2 plus z2 minus z1 for all power 2. By substitution about this rule, then AB equals square root bracket negative 4, negative 2 for all power 2 plus bracket contains 4 plus 1 for all power 2 plus bracket contains 2 minus 3 for all power 2 equals square root 62. By the same method, we find BC. Then BC equals square root 6. After that, we find AC by the same method. AC equals 56 under square root. How to prove that right angle triangle ABC? AB squared, you know that, equals BC squared plus AC squared. Why? Pythagoras theorem. Therefore, measure angle C, which opposite AB equals 90 degrees. Another example. Prove that the triangle ABC where E equals 4, 4, 0, B equals 4, 0, 4, C equals 0, 4, 4 are vertices of an equilateral triangle, then find its area. Dear student, look at when we find AB by using the distance between 2 points, 4 minus 4 for all power 2 plus 4 minus 0 for all power 2 plus 0 minus 4 for all power 2. Answer is square root 32. This is length of AB. After that, we find length of BC by the same method. Square root x2 minus x1 for all power 2 plus y2 minus y1 for all power 2 plus z2 minus z1 for all power 2. Then BC equals 4 minus 0 for all power 2 plus 0 minus 4 for all power 2 plus 4 minus 4 for all power 2. Answer is square root 32. We find AC by the same method. AC equal square root 32. What you know, dear student? Excellent student. AB equal BC equal AC. Therefore, H1 equal 32, square root 32. What is the area of triangle ABC? We have more rules. In this case, we use half product of two sides sine included angle. AB, BC are sine B. Therefore, half times square root 32 times square root 32 sine 60. Therefore, answer is 8 root 3. Now we are translate to another title, the coordinate of midpoint of line segment. Dear student, the midpoint of line segment in 2 dimensions, remember that if we have a point is x1, y1, B point x2, y2. The midpoint between A and B is x1 plus x2 over 2, comma, y1 plus y2 over 2. This midpoint between 2 points. In this case, we find the coordinate of midpoint in 3 dimensions or in the space. Look at the coordinate of midpoint in 3 dimensions. What is the rule? If we have point A, x1, y1, z1, point B, x2, y2, z2 in 3 dimensions, 2 points in the space, then the coordinate of the point C, the midpoint of AB. What is the rule? Then the rule is x1 plus x2 over 2, y1 plus y2 over 2, z1 plus z2 over 2. Look at example. If point A 1, negative 3, 2, point B 4, negative 1, 4. Find the coordinates of point C or midpoint of AB. Look at this point C. We add x1 plus x2 over 2, y1 plus y2 over 2, z1 plus z2 over 2. Find the coordinate of the point C. 1 plus 4 over 2, negative 3, negative 1 over 2, 2 plus 4 over 2. The first is 5 over 2, second negative 2, third 3. This midpoint C of AB. Remember, dear student, AC equals CB or AC half AB or CB equal half AB. Then when we find midpoint between 2 points in the space, we use the rule x1 plus x2 over 2, y1 plus y2 over 2, z1 plus z2 over 2. Answer is 5 over 2, negative 2, and 3. Now we are translate to equation of the sphere in the space. Remember, dear student, equation of the sphere. In the space, sphere has 3 dimensions. Look at this sphere. If we have center M, L, K, N, we have point A lies on circumference of the sphere A, X, Y, Z. The sphere is defined as the points of the space which are equidistant from a fixed point called the center of the sphere. And the fixed distance is called radius of the sphere. Dear student, we have 2 solid geometry. The first is called sphere, the second is called what? Circle. The difference between circle and sphere. The difference, circle in 2 dimensions, but sphere in 3 dimensions. The sphere is a set of points which is equidistant from a fixed point. This point is called center in the space. This center is point C, is X, Y, Z. When we have point belongs to the sphere, then MA is called radius of the sphere. Dear student, look at the equation of the sphere in 3 dimensions. The point X, Y, Z lies on the sphere whose center LKN and its radius R then coordinate to the law of the distance between 2 points, then square root x minus L power 2 plus y minus k power 2 plus z minus n for all power 2 equals R. This equation of the sphere. Remember, x, y, z point belongs to the sphere. LKN, center of the sphere. R is the radius. What is the radius? The distance between the center and any point on the sphere is called radius. This is constant. Then equation of the sphere equals square root x minus L for all power 2 plus y minus k for all power 2 plus z minus n for all power 2 under square root equals radius r. Then the standard form of the sphere is by second method. Bracket contains x minus L for all power 2 plus bracket contains y minus k for all power 2 plus bracket contains z minus n for all power 2 equals r square. The general form of the equation of the sphere becomes x squared plus y squared plus z squared plus 2lx plus 2ky plus 2nz plus d equals 0. The general form of equation of the sphere is x squared plus y squared plus z squared plus 2lx plus 2ky plus 2nz plus d equals 0. Remember, last year we have general form of the circle x squared plus y squared plus 2lx plus 2ky plus d equals 0. But the general form of equation of the sphere x squared plus y squared plus z squared plus 2lx plus 2ky plus 2nz plus d equal 0. This represents equation of the sphere of the center negative L, negative k, negative n, and radius r, where r equals, what is the r? Radius of the sphere, square root L squared plus k squared plus n squared minus d. Therefore, remember, L squared plus k squared plus n squared more than d. Why? Because, yes, the radius is positive distant. When L squared plus k squared plus n squared equal d, then r equals 0. No sphere. When L squared plus k squared plus n squared more than d, r equals square root negative, not exist. Sphere has no radius smaller than negative or smaller than 0. Radius must be positive distant or positive length. Then radius equals square root L squared plus k squared plus n squared minus d, and must L squared plus k squared plus n squared more than d. Dear student, find the standard form of the equation of the sphere whose center is 2, -1, 4, and the length of the radius is 3 units. Dear student, look at general form of the sphere, of equation of the sphere, x minus 2 square plus y plus 1 square. Why? Because y negative 1 becomes y plus 1 for all square, plus z minus 4 square equals r power 2, or 3 power 2 is 9. Look at another example. Find the equation of the sphere in which a point -1, 5, 4, b point 5, 1, -2 are the ends of a diameter. In it, the center of the sphere is the midpoint of AB. Dear student, what is the center? Yes, the center is midpoint of AB. What is the rule of midpoint? Excellent student. x1 plus x2 over 2, y1 plus y2 over 2, z1 plus z2 over 2. Then the coordinates of the center M is -1 plus 5 over 2, 5 plus 1 over 2, 4 minus 2 over 2. Therefore, MA is radius is equals what? Yes, square root x1 minus x2 over 2 plus y1 minus 1 y2 over 2 plus z1 minus z2 for all power 2 equals what? Square root 22. Then, at the first, we find the center M by using the rule of midpoint of AB. -1 plus 5 over 2 equals what? 2. 5 plus 1 over 2 equals what? 3. 4 minus 2 over 2 equals what? 1. Look at MA equals 2 plus 1 for all power 2, 3 minus 5 for all power 2, plus 1 minus 4 for all power 2 equals what? Square root 22. This is radius R. What is the equation, dear student? In this case, the equation of the sphere is equals what? X minus 2 for all power 2 plus y minus 3 for all power 2 plus z minus 1 for all power 2 equals what? R power 2. What is the R power 2? Square root 22 for all power 2 is 22. Now we are translate to another example. Determine the center and the length of the radius of the sphere, whose equation is x squared plus y squared plus z squared plus 4x minus 2y minus 6z plus 11 equals 0. Remember, dear student, in this example, we determine the center of the sphere and the length of the radius of the sphere. The general equation of the sphere becomes x squared plus y squared plus z squared plus 4x minus 2y minus 6z plus 11 equals 0. The coordinate of the center of the sphere, how to determine it? -1 over 2 coefficient x, -1 over 2 coefficient y, -1 over 2 coefficient z. By substitution, answer is -2, 1, 3. This is the center of the sphere. Remember, dear student, when we find the center or determine the center of the sphere of general equation of the sphere, we find the rule. The center is -1/2 coefficient x, -1/2 coefficient y, -1/2 coefficient z. -4 over 2, -2. -2 over 2, 1. -6 over 2 is 3. Then the center is -2, 1, and 3. After that, find the radius. What is the rule of the radius, dear student? Square root L squared plus K squared plus N squared minus D. By substitution about L, K, N, and D, we find the radius is square root 4 plus 1 plus 9 minus 11 equal square root unit. Dear student, by the end of the lesson, we learned that equation of the sphere in 3 dimensions, midpoint in 3 dimensions. Dear student, I am very happy to spend such time with you. Goodbye.